It's October 19th, 2025, RetroChallenge 2025-10, and here's my vlog update number 2. In my first update a few days ago, I showed you that in principle I have my rotating cube running on the MPF graphics card on my Microprofessor from 1981, but that I still occasionally observed a couple of glitches, mainly when I was rotating the cube. Sometimes the display was showing weird stuff like lines all over the place, etc. And also the CPU was crashing on occasion. Turned out that this was actually completely unrelated to the MPF graphics card firmware or the bus protocol, but it was actually caused by PicoRAM, in this case PicoRAM Ultimate, but PicoRAM 6116, the predecessor of this, would have shown the exact same glitches. So basically the issue was that I have analog button decoding here, right? So for the UI buttons, and you see every time I'm pushing a button here, the Pico is basically halting the SRAM emulation, right? And unfortunately, given that this is just a resistor ladder and using the analog converter in the Pico, this is very noisy and very unreliable button decoding, right? So you got to use analog thresholds basically in a wide range of values, allow a wide range of values, because these fluctuate so much, the analog levels that you're reading from these, that you have to write the code in a very robust way. And of course, whenever you push a button, basically the UI is, expected to do something. And usually I have HALT signal connected to the CPU basically, which would, when you operate a button, basically halt SRAM emulation, but first it would halt the Z80 CPU, because obviously you cannot, just stop RAM emulation and expect the CPU to not crash. But as you see here, I don't have the wait line, the wait signal from the CPU available, because the graphics card is also using this. And so the way for doing this is whenever I have to hold down, have to operate the UI basically for loading a program or so, I have to hold down the reset button on the microprocessor manually. And of course, if this doesn't happen, then the CPU will crash. Now, here I of course know that I'm pushing buttons and I have to, then hold down the reset button. But due to bad thresholds basically for these buttons, there is one button which is doesn't have a function basically in the top level UI, and this was detected basically spuriously. So sometimes the button decoder would basically detect a phantom spurious key press which actually didn't result in any UI action, and that would then cause the SRAM emulation to halt temporarily, right? And since the Z80 is not put in wait state mode, that would then crash the whole machine basically and produce these glitches, right? So that produced all kinds of errors, of course. Excuse me. So this problem is fixed basically. So the fix was, these thresholds for the button decoding for the analog threshold values are on the SD card in the init file. So the only fix that was really required was to change the threshold values for this button, which was spuriously detected, right? And so after this, the glitches with the cube and the CPU crashes were gone. But what bothered me was that I didn't get any visual indication that this was happening, right? Because if I'm pressing buttons here, of course, for most of the buttons I'm getting basically, of course, a clear visual signal, and also this LED goes on the Pico. But for this button, basically cancel to button, I did not have any visual feedback that this was happening in the background and basically messing up the SRAM emulation. So if this happens now, basically I was missing a default case in a switch statement which is doing the button decoding. So I put that in now, and if that should happen again, then we will now see an error message, right? So this will then pop up out of the blue, basically showing an error message that, spurious button press was detected, inaccurate ADC threshold levels on the init file in on the SD card. So that way we know what's going on and what is causing this, right? But you can't just have, you know, things happening in the background, halting SRAM emulation, right, and not making the user aware of that. So I pushed a firmware upgrade, basically, that shows the error message now. If that should happen again on the display, so the user is aware of it, both for PicoRAM Ultimate, this one here, as well as the predecessor PicoRAM 6116. So if you're using PicoRAM by any chance, right, SRAM emulator and SD card for single board computer systems, currently I support the Microprofessor, the Heathkit ET3400, and another 6502 based trainer, the LabVolt trainer, and also the Philips MC6400, the Master Lab. So if you want to know more about the supported machines and PicoRAM, check out my GitHub and the videos I made. So, but yeah, with regard to the software side of things, I said that I wanted to basically make it so that the cube can automatically spin, right? And for this, I decided now to, oops, I loaded the Mandelbrot program here, so let me load the cube again. And so I have a little progress to share there, which is the main update here in this video. Basically, I can now make the cube spin. I have a lot of software by now. There it is. Basically, I can now record the button presses for the different operations, right? Plus, for example, is the zoom in, so cube gets a bit bigger on the screen, and then you can now use these buttons to rotate along the axis. And now these button presses are actually being recorded into a record buffer, and I can then play that back, right? Let's record it a bit. And then you can also make it smaller again with minus, it zooms in. And then with 0 you reset the cube and it ends it. And then you can just play back what was recorded by pushing the go key. And you see it's not super fast yet, but I do think that this is basically caused by the graphics card. In order to clear the screen for drawing the next frame, I use a background fill operation, and this is pretty slow. Also, double buffering is not implemented yet. And note that in order to drive this graphics card, right, it's actually using the weight pin of the Z80, so you don't have to program delays or poll basically the port to know when the graphics card is available again, because I mean that's just a humble AVR 80 mega 128.4p at 16 megahertz, right, running the Adafruit graphics card. It's doing a lot of stuff, driving the SPI display and all that. So it's not the fastest, but I still want to try to make it faster, right? I mean, it would be one thing, of course, to try would be, instead of using background fill, right, to clear the screen again, we could simply redraw the cube one more time, but with black, right? Then it would be erased from the screen. Yeah, that's an option I could try. And then there's also still the flickering. You see there's no double buffering implemented yet. So basically the way the graphics card works and the protocol with the Microprofessor is, so the Microprofessor sends a bunch of draw line, basically drawing commands, right? Those go, oops, no, it's blurry. Please focus again. So those get into the record command buffer of the graphics card, and then basically you send another opcode and enter. FF in this case, and this causes basically playback of the whole command loop, instruction loop on the graphics card from its buffer. It also has a 256 bytes command buffer, so it draws the lines and also the clear screen at the beginning of that. draw a rectangle basically as fast as it can, right? So the flickering is actually not caused by the microprocessor because, like I said, the commands are queued and then played back in one batch by the graphics card, but it's really the processing speed of the MPF graphics card and the 80 mega. But of course, I mean, the microprocessor needs to compute the points, floating point arithmetics, and trick basically, which isn't entirely trivial. So, but this part of the software was already written by the original author, from whom I ported and adapted the code, right? So, what was his name? Brian Sheeha. Alright guys, so this is my update for the RetroChallenge vlog update number 2. Making progress, so what's left to do? Not too much, so basically try to speed up the graphics card firmware a little bit now, like I said. Instead of erasing the background with a draw rectangle, I could try repainting the cube in black. And then I also want to still implement double buffering so that the flickering is not that noticeable. Alright guys, thanks for watching, take care, until next time, bye.